Okay, so 7.3 is independent and dependent events. And we're going to identify whether events are independent or dependent. And then we're also going to learn about conditional probability. So it's the probability of finding something when something has already happened. And we'll go over some examples of that. We'll also use a table. So we're going to start with the independent events. Do you guys know what the independent variable is most commonly in math? X, right? Because whatever y is, it depends on x. Okay, so x can stand alone, but y is the dependent variable. So an example of an independent event would be a coin toss. So if you toss a coin and you get a heads one time, the next time you toss a coin, it doesn't matter what you got the time before, you still have the same amount of chances, right? Which we talked about yesterday. You have the 50-50 chance or the 1/2, 1 out of 2. And then rolling dice is another situation that is independent. So when you're calculating the probability of independent events, what you can do is take the probability of one event and then multiply it by the probability of the other. Okay, so for example, if you are tossing a coin, okay, if you want to know the probability of getting a heads, it will be 1 out of 2. If you want to know the probability of getting a heads twice, it will be 1/2 times 1/2. So if you do a coin toss twice, it would just be the 1/2 times 1/2. Okay, so getting 2 heads in a row, you have a 25% chance, okay, for 1 out of 4. All right, so we're gonna use that equation today to help us solve events. So remember, the capital P means the probability. This is the probability of the events A and B, and then you just have to multiply those together. We are going to finish this first. Okay, and then for example 1, we have a 6-sided cube. It is labeled with the numbers 1, 2, 2, 3, 3, and 3. Okay, so you have a 6-sided cube. It's labeled with the numbers 1, 2, 2, 3, 3, and 3. And then 4 sides are colored red. 1 side is white. And 1 side is yellow. Okay, find each probability. So the first one is a probability of tossing a 2 and then tossing a 2 again. So what we're going to do is find the probability of tossing a 2, and then we're going to multiply that by the probability of tossing a 2, because those are independent. So first, the total on the bottom, the total number of outcomes, is the total number of sides. So for a 6-sided cube, your total on the bottom is going to be 6. And then on this cube, how many sides have 2 on it? 2. So it'll be 2/6. And then we're just going to reduce the fraction. So if we reduce it, we have 1/3. Okay, so then all you have to do is multiply the probability of getting a 2 and then getting a 2 again. And then you're going to multiply fractions. So multiply straight across. 1 times 1 is 1. 3 times 3 is 9. So the probability would be 1/9. Okay, and then for part B, you have the probability of tossing a red, then a white, then a yellow. Okay, so again, this is an independent event. So we're just going to find the probability of tossing a red, then a white, and then a yellow. We're just going to multiply them together. You always want your fraction to be reduced. Okay? So for the red, what we're going to do is just look and see. There are 4 sides that are colored red, and there is still a total of 6 sides. So tossing a red would be 4 out of 6. And 4 out of 6 is going to reduce to what? 2/3. So that's what I'm going to put here. All right, how many sides are white on this cube? 1. So it says 1 side is white, so 1 out of 6 sides are white. It's going to multiply by 1 out of 6. And what about the yellow? How many sides are yellow? 1. Right? So 1 side is yellow, 1 side is white, 4 sides here. So 1 out of 6. Okay, so then we're just going to multiply straight across and then reduce. Okay, so 2 times 1 times 1 is 2. 6 times 6 is 36. 36 times 3. You just can use your calculator for that. 108. And then you have to reduce. So think of our reducing rules from yesterday. This one is pretty simple because they're both even, right? So divide by 2. Half of 108 is 54. So the probability of that is 1 out of 54. Okay, we are going to be writing our answers as fractions today. And then just make sure that you always reduce them. And most of your Chapter 7 test is going to be written in fraction form. There are going to be some where you'll have decimals or percents, but a lot of fractions. Okay, then go ahead and do C. So you go did an A and B to help you, and then I want you to do C. Okay, so for the first one, the tossing of 3, Dylan, can you tell me what the probability just is of that, of tossing the 3?
3.
Good. So there's 3 out of 6 sides, so that would be 1 over 2. Okay, and remember, it just goes back to this. So there's 1, 2, 3 sides with the 3's on it. All right, and then Seth, how many sides are yellow? 1, so 1 out of 6. And then Dane, how many sides are red? 4 out of 6, which is 2/3. So when you multiply them all together, you do 1/2 times 1/6 times 2/3. And then if you guys want, you can multiply across and reduce, or, look, isn't the 2 and the 2 going to cancel out? So you can just do 1 over 18 here. Okay, or you get 2 over 36 and then reduce. All right, the next thing we're going to talk about are dependent events. Okay, so a dependent event is when the occurrence of one event affects the probability of another. Okay? So that common occurrence of pulling marbles out of a bag that you do not replace. You guys have marbles in your city? I did too, but I didn't play marbles. Did you guys actually play the game of marbles? Yeah, it's you have like a circle. You have a circle. You have the marbles in a circle, and it's like you have to shoot them out of the circle. I'm gonna go home and ask my dad if he ever played. Have you guys seen like one of the real the live action Peter Pans? No? Do you guys remember Toodles? Toodles always had his marbles and Hook. You guys seen the movie Hook? Ruby, oh! Yeah? John Williams? Yeah. Peter Pan. I just remember in that movie the character Toodles was always carrying his marbles around and was in his examples. Literally and figuratively. But something that's more common is the drawing the card out of a deck without replacing it. So we're going to do some examples with that today. Do you guys like playing cards? Do you guys have a favorite card game? Poker? Garbage? Never heard of that.
Trash? Yeah, like,
What are other ones? Nobody like euchre in here?
Oh,
I'm so
euchre's
confused.
fun.
I don't know how
That's
to
not
play it.
poker.
I remember being little and all the adults would be playing euchre and it's like, I wanted to learn how to play. So I could sit at the big kids table. Yeah, yep.
We need to do like a probability card thing.
We are going to do a probability game next week. We're going to be using that.
You're on the way.
We will teach her. We will teach her. All right.
What is it?
It's a game of dice.
Oh.
Yeah. So very common instances that we're going to talk about. We're going to talk about the cards in the deck. We're also going to talk about rolling dice. So when it says 2 number cubes are rolled, that means 2 dice are rolled. Now for the dependent events, there's a different formula. And I did write out what it means, but let's talk about that. So the probability of dependent events, A and B, you have to take the probability of A and multiply it by the probability, and this means the probability of B given that A has occurred. Okay, so the probability of the second event given that the first event has already happened. Okay, so for example 2, you're just explaining why they are dependent. I'm going to show you how to do that. And then you're going to find the probability of the event itself. Okay, so when you are ready, you can go to page 2. All right, so we're going to find the probability that the white cube shows a 6 and the sum is greater than 9. Okay, and then the first thing is explaining why they're dependent. Hi. Who is it? For how long? 3 minutes is fine. Okay. All right, so the first part is just explaining it. So the probability that the sum is greater than 9, okay, that is different when we know, I'm just going to say when a white 6 has already been rolled. Okay, and the reason why it's different is because if you don't know what the white cube shows, right? Like if you rolled a 1 on the white, okay, you wouldn't be able to get something where the sum is greater than 9. So your probability would change. Our probability for this is going to be higher because we already know it is possible. If you roll a 6, there are going to be numbers that get you to a sum that's greater than 9. Okay, so the first part, the explanation, that's all you have to say. Step 2, we're going to use the formula. So the formula is the probability of the first event happening. You have to take that into account, and then you're going to multiply the probability of B given A. So built into this probability of this whole event, which is really these 2 events, okay, you have to find the probability that you roll a white 6. Okay, so 6 on white. I'd be fine if you said white 6. This is just how I wrote it, and then it made me think of ordering sandwiches. I'll have the number 6 on white, please. So the probability that you do roll a 6 on white is what? So it's a number cube, so there's 6 sides, okay? And for this one, we're using a standard number cube, a standard die. So how many sides have the 6 on it? 1. So it'll be a 1 out of 6. Okay, now the probability of P, given that A has happened, this means the probability that the sum is greater than 9, given that you have the 6 on white already. So I'm a visual person. I need to see my choices and what's happening here. So I'm going to make 2 columns, one for the white cube and one for the yellow cube. Okay? Now the white cube we already know. The white cube's a 6. Okay? The yellow one, though, what are the possibilities that yellow could be in order to get a sum greater than 9? Could be a 4, it could be a 5, it could be a 6. So how many choices is that? 3. Okay? So it would be 3 out of 6 sides. So basically, you have a 1/2 chance, 50% chance, that you would roll one of these numbers. And again, this is one roll, so it's 6 is the total. So to find the probability, and then at the end, when I put the probability, I just put of the event, so I don't have to write all that out again. So the probability of the event is 1/6 times 1/2. So your probability is 1/12. Okay, now the next one is a little bit harder, so I'm going to help you with this one too. The first part you'll be able to do pretty easily. So for B, the yellow cube shows an even number. And the sum is 5. So the first thing we're going to do is the explanation, okay? So again, when you're thinking about the sum is 5, the probability that the sum is equal to 5 is different when we know an even number has been rolled. Okay, because if we didn't know that, there would be more combinations. Alright, so for part 2, it's the same formula. Can you guys find the probability of event A? What is event A in this case? Yes, the even number. Okay, so probability of A is that the yellow cube shows an even. So again, for that yellow cube, there's a total of 6 possibilities. How many even numbers are there on the cube? 3. 2, 4, and 6. So that's going to give you 3 choices. So 3/6, or 1/2, is the probability of A. Okay, so the probability of A is just this event. Okay, the probability of P given A, that's what we're going to calculate. Okay, so that's the probability that the sum equals 5 when we know yellow is even. So again, I like to write out my choices. That helps me understand what my total is, and you'll definitely want to do that for ones like this. Okay, so the yellow cube, how how many choices do we have for the yellow cube if it's even? We have 3 choices, right? You have 2, you have 4, you have 6. This is a little bit different than what we had before, because see how we only had one option for this cube? Okay, that's why the denominator was 6. When we do the next one, the denominator is going to be different, okay? So for the white cube, let's think of our possibilities. Now, if it's a 2, what would white have to be so that the sum is 5? 3. For 4, it would be 1. And for 6, not possible. There's nothing you could roll on the number cube that would make it the sum 5, right? Because you can't roll a -1. So, how many choices do we have in this column? 2. Now, it's not 2 out of 6, because how many times would each one of these be? This would be out of 6, this would be out of 6, and this would be out of 6. So yeah, so 6 and 6 would be 18. So it's going to be 2 out of 18. So again, where this comes from is when you are rolling, each one of these has a chance out of 6. This one only had one chance, right? White was only one roll, okay? This has 3 different rolls, okay? So the total here is like, this is 1 choice out of 6 that happens. This is 1 choice out of 6 that happens. The not possible is 0 out of 6. So the 6 times 3 is where we get this. Or whichever one you want to think of it. The 2 comes from the 1 and this one, okay? 1 plus 1. So when you're trying to find the total, you are adding the amount of rolls. Yeah.
How did we get the 3 and 1 not possible?
Oh, so it's you're trying to find when the sum is 5. So if the yellow was a 2, because yellow can be any one of the even numbers. The yellow was a 2. In order to get the sum is 5, this would have to be a 3.
Oh, okay.
And then this would have to be a 1, and then there's nothing you could roll that would give you that. And what is 2 out of 18 reduced to? 1/9. Okay, so then when you multiply those together, okay, the probability of the event is 1/2 times 1/9, which will be 1 over 18. Okay, so all of the different conditions here is what's going to help you with your total. All right, now we are going to go to using a table, and when you are using a table, you're going to find what's called conditional probability. And it is just based on certain conditions. So the example that we're going to look at, you have a table that shows the domestic migration from the years 1995 to 2000. Okay, and then a person is going to be randomly selected from this group. You're going to find the probability, and we're going to write answers as both a fraction and a decimal. Okay, so the table itself, you would be given all of these values. Okay, these values will be given to you in the table. So this is 2410. This one is 2808, 3243, and 2654. Okay, so you would be given a complete table. Do you guys know what domestic migration means? No, one of my AP macros. Yeah, within the U.S., within your country. Okay? So the first one we're going to look at it says an immigrant is from the West. An immigrant is from the West. So what this means is you are given that they are an immigrant, and you're finding the probability that they're from the West, given that they are an immigrant. So that's the symbol for given, okay? The language with these is what's going to be important, because that's going to help you determine what the total is on the bottom. So for this, if it's given that they're an immigrant, this is going to be the total number of immigrants on the bottom, whereas on the top, we're going to be looking for immigrants from the West specifically. Okay, so find the probability that an immigrant is from the West. So to find the total number of immigrants, what are we going to have to do here? We're going to have to add them together. Okay, so we're going to have to find the total. And then eventually we are going to need to total this as well. So if you guys just want to total both at the same time. Okay, and you can use your calculator. Okay, so let's do this one first. How many immigrants are there? 11,000. Yeah. Okay, so that's what's going to go on the bottom here. Now on the top are immigrants from the West. So the West immigrants is the 2654. Okay, it says we have to write this as a fraction, so we are going to reduce it using some of those rules from yesterday. I can see these are both even, okay, and then if they're both even, we're just going to cut it in half. So reduce. Could you look? Yeah. You want to be like this. I know. These are kind of intense fractions. And then we're going to round to the nearest hundredth. When we do that, make sure that you're looking at the number behind the hundredths place. Okay, so that's going to be about 0.23. All right, and then on the next page, this is again going to be using the same table, so we are going to kind of flip back and forth there. So this one says someone selected from the South region is an immigrant. Okay, someone selected from the South region is an immigrant. So this is another one where one of these is given. So what do you guys think? Which one is given? Yes, so somebody is selected from the South region. That is your given part. Okay, so you're finding the probability that a person is an immigrant given that they are from the South. So on the top is going to be immigrants from the South. Okay, over the total number of people in the South. So the immigrants from the South over the total number of people in the South. So to find the total in the South, how do we do that? Yeah, you add together the immigrants and the immigrants. those two together. And that's going to be our denominator. And then the numerator are the immigrants from the South, which would be the 5,042. Okay, so this is going to be the 5,042 over the 8,285. Okay, you actually can't reduce that. This one is even, doesn't end in 0 or 5. The other one does, so we're going to leave that, and then let's go ahead and round. 5042 divided by 8285. All right, so we got to round this to what? 0.61. All right. Now, C is worded a little bit differently. So this one said someone selected from the South region is an immigrant. This one says someone selected is an immigrant and is from the Midwest. So here we have this and, right? There's no given in this one. Okay, someone selected is both of these. So when those happen together, okay, you won't have the given, you'll have the and. So it's the probability that they're an immigrant and Midwestern. I don't know why I put that there. I thought I was going to abbreviate it. Okay, so let's find the probability. So this is different. Because it's an and on the bottom, you want the total number of people in that table. And then on the top is going to be the people that are both an immigrant and from the Midwest. Okay, so let's find the total number of people. And when you're finding the total number of people, you're just going to be adding those together.
Do you mind if I borrow an ask for your book?
Is it going to be less than 5 minutes?
Yes.
Okay. Yep. All right. And so when you're finding the total, I had you find these two totals for the two columns. What did we get for this column?
11,685.
Good. So now that we have both of those to find the total, just add these two together. So when we add them together, it'll be 23,311. That's the total people. So that's what's going to go in the denominator. So 23,311. And then for the immigrant and Midwest, we're going to find that box. So Midwest, immigrant, 2951. This is our fraction. And then we're going to calculate our decimal. All right, so I have to round this one up as well. Okay, so let's look at D. Is D more like B or C? Let's look at the language. So someone selected is from the Northeast and is an immigrant. What do we think? Yeah, it's more like C, right? What's a key word that's in C and D? That and, right? So someone selected is from the Northeast and is an immigrant. So that means you're going to do the probability from the Northeast and immigrant. so that goes on the top. And then the bottom is the total number of people. So the same total as last time. So it's still the 23,311. To find the numerator, all we have to do is find the box in our table. Okay, so northeast and an immigrant, let's look. Northeast, immigrant, 1537. And then we are going to reduce. Okay, so you have 0.06, but that 5 rounds it up to a what? 7. Okay, great. All right, and then finally we're going to talk about some cards. So, 2 cards are drawn from a deck of 52. Determine whether the events are independent or dependent, because that's going to change how you calculate the probability, okay? And then for these, we're going to find the probability as a fraction. And just so you know, like on your chapter test, most of them are going to be fractions, so you just have to make sure you reduce it. Now, in order to do this properly, we have to know a few things about cards. So if you don't already know, in a deck there are 52 cards, okay? So a deck of cards has 52 total. And then the other thing you have to know is how many suits there are. How many suits are there? 4. So if there are 4 suits, how many cards are there of each suit? 13. Just divide, right? So 13 cards of each suit. Okay, and as long as you know that, you can find your probability. So the first one says you're selecting 2 hearts when the first card is replaced. So that means you put it back in the deck. So is that going to be independent or dependent? Independent. Okay, so if it's independent, you can just multiply the probability of getting a heart times the probability of getting a heart again, because that's what your 2 hearts is. Okay, so what's the probability for the first one? How many hearts are there? 13. How many cards are there total? 52. If you put the card back, how many cards are there? Still 52. Yeah, and there's still 13 hearts. Yes. Yeah. I switched it up. Okay, so if you put that card back, yeah, there's still 13 and there's still 52. Now, you could multiply those together, but then you get a big number and you have to reduce it. That's fine, but let's reduce it here. What's 13 over 52? How many times does 13 go into 52? 4 times. So it's just 1/4 times 1/4. So it would be 1 over 16. All right, now for B it says selecting 2 hearts when the first card is not replaced. So is that independent or dependent? Dependent, because it depends what you draw the first time. Okay, so we're going to do the probability of a heart times the probability of a heart, given that a heart is already drawn. So the first one you draw, same thing as we did before. Probability of the heart is 13 over 52. But the probability of a heart, given that you already drew a heart, what does that do to the bottom number? -1. Reduces it by 1 because you have 1 less card, right? So you have 1 less card total. And then what about the top number? Does that get affected? Yeah, so what's that going to be? It's going to be 12. 1 less heart. Okay? Sometimes they might do like, oh, a heart given that a club was drawn. Well, the club isn't going to affect the top number, only the bottom. So again, when you are multiplying, let's reduce it first. So 13 over 52 is 1 over 4. And then, do you guys remember the trick yesterday to see what number goes into both? So 2 doesn't go into both, but how can we check to see if 3 goes into 51? Yep. So 5 plus 1 is 6, so it'll go in there. And Ava, you already calculated that, right? What did you say you got?
417.
Good. And then look, what's going to happen with the 4s? Those are going to cancel, so 1 over 17. Yeah. All right. Now the next one is a queen is drawn, is not replaced, then a king is drawn. Okay. So if a queen is drawn, not replaced, and then a king is drawn, is that independent or dependent? Dependent. So really, anytime we have a card deck, if it's not replaced, it's going to be dependent. So we got to find the probability that a queen is drawn, and then we have to multiply that by the probability that a king is drawn, given that you've already drawn one queen. Okay? So how many queens are there in the deck? 4 out of 52. Now, if you don't replace it, there's 51 left. Okay? If you've already drawn a queen, how many kings do you have left to draw? 4. There's still 4 kings, right? Okay, so then reduce 1 over 13 times 4 over 51. This does not reduce, because 2 won't go in there, 4 won't go in there. If 2 doesn't go in there, 4 is not going to go in there. Okay? So multiply across. 1 times 4 is 4. 13 times 51, when you calculate that, you should get 663. Okay, so this is your chance. Right? So if you've drawn a queen, look at how low your chances are of getting a king. 4 out of 663.
So wouldn't they be like higher than getting another, or just randomly getting another?
Really, any other card is going to have that probability. All right. Because there's 4 of each type of card. There are 4 queens, 4 kings, 4 fours, 4 eights. Yep. Because there's 1 of each suit. So the 4 suits, the heart, the diamond, the spades, and the clubs.